Thank you very much, Professor Kumaralai, for the nice words in the introduction, and welcome. Myself, Dr. Preeti, the CEO of Technology Business Incubator of NIT Calicut, and for having here the contributing a little bit to the entrepreneurship ecosystem inside and outside the campus, generally into Kerala's entrepreneurship ecosystem. My topic here, as you have seen from the brochure, is basically to tell you about the assistances offered to you for the prototyping. I would definitely like to do that, and plus would like to tell you about a little bit about the incubation activities that we're doing here, which is again from anybody from other institutions can always join us. As Sir was telling, we are in the process of forming a chain of IICs, Institute Innovation Councils, in different institutions, mentoring them, hand-holding, or rather, of course, with a little more experience in the entrepreneurship development area. I'm audible, right? I'm audible, right? Right. Okay. So this is the entrepreneurship is basically a collective activity. A single person just in isolation will not be able to do much in entrepreneurship except for the idea generation and just a little bit moving forward. That's all. So apart from that, I mean it's a collective process, and we need to have a collective working towards achieving a good product or a good company. Okay. So let me all welcome you first to the NIT campus for those who are from outside, and to this workshop especially for the NIT students as well on prototyping assistances. See, prototyping, first of all, we should think why prototyping? Why you need prototyping? Because, see, we can always think of growing something, establishing or setting up a big plant or factory just directly to make a product. Okay? Prototyping is most essential when you are dealing with a new product or a good technology product. Right? A normal one, which is already much tried out in the market, probably will not require prototyping because it is already there. It has seen the market, and or other people know how to make it. Prototyping is basically a kind of optimization to see whether it is actually working according to the requirements. For any product idea, it starts from an idea, right? Any product starts from an idea, right? Or starts from basically a requirement in the market. Any product or service which is oriented towards the market or oriented towards the customer only will succeed. That's a basic principle of marketing. You must have seen everywhere that customer is the king, even though it is not considered so in most of the cases when it is becoming more and more elaborate, right? So the thing is, customer orientation or market orientation is an important thing in any product development. Get the product successful in the market. Ultimately, why do you need business or why do you need products? It's not making profit. Okay. For academicians, probably the academicians might feel that profit is slightly not so good to talk about. But for business, it is profit. Okay. Each minute of your time, each paise, okay, it has to bring you profit. Then only your business will succeed. Right? Okay. So everything is counted in business. Nothing is free. If something is free, there is get it please. Something wrong behind that. Okay. So just take this from me. Everything you need is for making. Okay. So what we do is, so when you actually go to the market, we have to see whether it is going to be really successful or not. So first it starts from the idea, because idea starts from some requirement. Okay, why this mobile phone was invented? Because many people, fortunately, were not able to get connected when they were traveling. Okay, when they are stationary at home or at office, it's fine. Okay, you can get connected to anybody, right? But when you are traveling or when you are outside the premises of the land phone, you have to call, right? So that was a requirement, but the requirement got optimized through many years to this form what we have it with us now, right? So for I'm talking about a requirement from the people around us. Okay. So first, for anything, for becoming a successful entrepreneur, to start with, you've got to have a very good scanning of the environment. Some chances might just like occur, okay, when you might come across, or it could be even your own requirement, or you see around, okay. But if you are actually going for to start a business, when you really have some money, you have some technical knowledge and all, definitely we have to start scanning the environment for opportunities. So okay, fine, you got an idea, you got some kind of a technical knowledge about it, okay, but not fully, okay, probably not fully. Because for anything, if you are going for a technology related products, you might require a lot of inputs. Because technology is nowadays changing very fast, right? So we need some, first of all, whether we have an idea, we have some, requirement which we have already identified, but we have to see whether our idea is really going to work. It could be based on some concept, like especially the students and faculty like you have a lot of knowledge, scientific and technological knowledge. Okay? With your knowledge, with your theory, probably you feel that okay, something is workable, but we have to test it out, right? So in the lab, you can test it out with a proof of concept. So there you are actually, telling that okay, this is a proof of concept. The concept that I am having, the idea that I am having, can be changed, or rather, it is working. It is giving the desired output technologically. That is only technologically. But when you actually go to business, you require a lot of other things. The first and foremost thing, which is profitability of the product. Many things are there which will work technologically. Maybe some of the electrical students here will be able to think about the concept free energy. You have a lot of ways of making the free energy. There is a free energy concept, but why are we not able to produce good quantum of energy out of this kind of principles? Basically because, of course, you may be able to prove your concept, but beyond that, practically, it may not be possible. Practically, it may not be possible. Practically, it may not be profitable. Okay, so we are actually seeing, prototyping, that is next stage is prototyping. First is the idea. I'm sorry, I did not connect my laptop. My laptop has got a small connection problem. Did not have a connector in this. Left in the office, forgot the office key. That's right. So, the thing is, I'm just taking you through the journey of prototyping to the product. Okay. So first you have the idea which you derive from the market, and then you have the theory in you which you want to first try it out in the lab, in the in the way of making the proof of concept, POC we say. Okay, and then of course you have the POC proof of concept done, but for them, of course there is a lot of difference between the proof of concept and even the product. Of course it is too far from the product finally. Okay, so. As I told, proof of concept is just checking the theory that you have about the product or about the invention or about the business, that's all. Okay? So the next step is prototyping is like you have a lot of difference over there from the proof of concept. It is more near to the final product. Okay? So there actually mostly you have to use almost similar materials of what you are using for the almost. I am not telling completely, okay? Because you are going to see in the coming sessions how you make prototyping, how you do the prototyping, even the additive manufacturing techniques and all, where you are not probably actually using the correct kind of material. You can use plastics, different kinds of plastics and all. There probably you are going for the final enclosure as a metal. We have experts over here for doing that. Okay, the prototyping side, additive manufacturing side. Okay. So this is like, of course, the prototyping will finally give you the shape, size and the functionality, mostly functionality of what is going to be the final product. In shape, in size, okay, and in the functionality, it has to be similar to the final product. then only you will be able to say a functional product. Okay, so proof of concept, you probably need a smaller one, a bare one without any enclosure or without any proper connections or whatever. Okay, you're just checking whether actually the desired results are coming out or not. Now the prototyping, you will be able to get some idea of how it is going to be the final cost also. How much time, how much cost, how much was the size, everything. You will be able to identify, we will be able to decide with prototyping. Okay, and the prototyping will tell you, okay, how much money you require, or probably for the actual customer also. If you give the prototype, they will get a somewhat feel of how the product is working. But it is not a product or a thing which you can sell in the market. But you can see whether it is actually working with the prototype. Okay? Of course, the prototyping is probably, you can give it to the ultimate user, consumer, the customer. Probably you can actually, or that person can actually use it and give you the feedback. Prototyping, the most important, or rather one of the most important reasons why we do prototyping is basically getting the customer feedback. Okay, so customer feedback, the cost estimation, the functionality testing, these are some of the major reasons why we are going for prototyping. Okay, so this will actually give you a correct idea of how the product is going to be somewhat the end. There are many methods. Okay, depending on how it is going to be, you can do the prototyping. Okay, in some cases you might require the technologies like additive manufacturing. Maybe you can make the model of 3D or something. Okay, everything we know is very good. Just a one way of making it. Okay, which you will see later in the day. So these are some of these are some of the reasons why we do prototyping, and will give you a correct estimate of how much, or rather we can estimate on how much cost, because once you do the prototype, you will get the size, you will probably assume the weight. Okay? Even if you are doing it in the plastic, prototyping is done in the plastic, probably at the end, how much you get, since you get the size, you can calculate with the other material how it is going to be if you are going to do finally metal. Now once the prototype is getting ready, you can move to the minimum viable product, MVP. Minimum viable product is something which you can use for test marketing also. Minimum viable product will be having only the basic functionalities. These are the two things, okay, about the MVP, right? MVP you can actually distribute, or rather even sell to the clients, sell to the customers, okay, with probably a reduced price or whatever negotiations you can make with the customer. Right? Okay, so that will actually is probably you can even sell. That is something which you can sell for price, and which will get you. This is being used for the test marketing. You know what is the test marketing, right? Okay, you're actually making the product with the limit for. Of course, you are probably aiming at a product for all India. But when you say, when you're test marketing, you will select only some particular location or some particular segment of the market. You know what's a market segment, I suppose? You have the complete world as your market, or if you have a big, the entire human being as your market, but you have different segmentation for the market. It's like either men and women, or it could be youngsters, it could be all people, it could be small children, so it could be anything, or it could be Indians, it could be Keralites, it could be people from the city, it could be people from village. So there could be the total market could be segmented in different ways. Okay, so to a selected market segment, to a selected location, or to a sample of the total entire market, you can actually give the product, okay, give the the basic product and see what their responses are. This is called the test marketing, wherefrom you get a lot of feedbacks, okay, for correcting the product. Because MVP stage again, you have to probably do a lot of corrections to come to a final commercializable product in a large way. Okay, so this is normally the product journey from idea to proof of concept to prototype to MVP to commercialization. So in this one, actually prototyping is one of the most important stage where you are actually converting from theory or from the idea to the product. It's a jump to the from idea to the product. That's why we call it prototyping is important. You can say probably around I will just come to the assistances that is required for prototyping. Then I will see how the normally the agencies are envisioning the method of prototyping. Okay. So of course you need the idea for prototyping. One more things you require for prototyping is like you need first of all a viable idea. Okay. You have to check the validity of the idea, and the idea of validation is to be done with the proper market survey. Okay, I told you the customer requirement is the most important thing. Okay, which you have to first theoretically check with market survey before venturing into, because prototyping itself might cost a lot in many cases. So what will happen is, unless you study the market properly, it will end up in wasting time. So first we have to do a good market survey. You have seats there, right? Okay, so we have to do a good market survey and then go for the proof of concept, the next stage of finding out a prototype before using the money. Because any method of prototyping will require some amount of money. Okay. So the validation of the idea is to be done first, and then you go to proof of concept level, and then you go for the prototyping. For prototyping, you require some kind of infrastructure development. For technology-based product, you need some machines, or of course you might be having a 3D printing demo today, which is actually essentially telling you that you require some machines to do the prototyping or some lab for testing. Okay, I am talking about the product development, technology product development. Okay, so because prototyping is the thing for technology product development, right? So you require some machines, some equipment, some infrastructure, and most importantly, funds. Okay, so about the infrastructure side is where these kind of incubation centers and institutions can help out. Okay, because all these machineries, lab and all those things, what you require, what you have in the institutions is good enough for prototyping. Okay, because you're not going to commercially produce, because commercial production will require your product line and your production line and everything. But for prototyping, you require small machinery, or rather the machinery which you can use. It is just one or two making one or two products, right? One or two crude forms, right? So which require only your probably lab equipment. Most of the cases, maybe some cases you might have to go out and do something where the machinery is not available in your institutions. NIT, in the places like NIT and maybe many of the engineering colleges, otherwise you will have some good facilities for the prototyping process. Okay, the normal things. Okay, and mostly many of the places we have the fabrication laboratories, which we call fab labs. Okay, which is the ideal place for prototyping. Okay, so we have very good fab labs in Kerala, Trivandrum with IIITM, which is now the Digital University. You have a very good fab lab. Okay, and Cochin Maker Village, you've got a very good fab lab. In fact, a very big one. In fact, where you get almost all the machineries you might require for prototyping. We are also setting up a small fab lab, not very big, with just around 1 crore plus worth of equipment, with 3D printer, laser cutter, CNC router, then vinyl plotter, then PCB milling machine. So all these machines we're having in our fab lab. We're setting up in another 2-3 weeks. It should be open. Okay. So there are these fabrication laboratories which you can use. In fact, Calicut University is planning to set up one. I mean, maybe they are in the process of doing it. So there are in many other colleges. Kerala Startup Mission has helped many colleges, engineering colleges, set up mini fab labs. You must have heard about the adult tinkering labs in the schools, right? Many schools are having the adult tinkering labs. In fact, these adult tinkering labs is the smaller level prototyping facilities, very smaller level. Okay? The scaled down model of these fab labs, which is set up in the schools. They do have smaller 3D printers, small sensors, and all those kind of things, like the basic infrastructure which the school kids can use for their testing on the probably actually, this is all these facilities are set up by the government, central government or state government or something, with their government funds mostly. Okay. So what happens is, actually all these supports are given to the education institutions basically to support the technical product development in these institutions. Okay, because the institutions is where the inventions are made, the theories or the practical applications are made. When you are given with the theories, knowledge and the things to work on, it's the best situation to convert it into a product. Okay, so this is the situation that the Fab Lab probably originated from the MIT US. So the MIT's full-fledged Fab Lab is set up in the Digital University of Bangalore as well as in my native village. But all others are the miniature versions of the original MIT Fab Lab, the basic equipment and all. So when you have something to, of course, for the students over here and maybe somebody over here, I can always direct to Native Village or for any of your working, if you are not able to get it done here. Okay? We can offer you all these activities because many of the students have already come to DBI to get the 3D print model of their projects and all. So we have, of course, there is a small cost, but still, it's comparatively from the market rate, it is very cheap. So this is a cheaper facility being offered to this incubation. Of course, it is not compromising the quality, but the low cost or rather the affordable infrastructure being given to the innovators, for their validating the idea. Okay, so this is the infrastructure side, and definitely all the departments here, and definitely many of the engineering colleges will be definitely having most of the machinery which you require for prototyping. Okay, else you have to search for it where you can get it. Just get connected with any of us. We will be able to guide you which institute or which facility, which place will be having all these facilities, and we will go there and okay. So now the thing is, the advantages, most of the institutions like like what Murali sir was saying in the beginning, the Institute Innovation Council, we have maybe around 1,000 Institute Innovation Council all throughout India. In Kerala itself, we have plenty in number, in fact, IICs. Okay? So everybody is very much familiar with the concept of innovation and this incubation activities and also anywhere you can get the kind of assistance that you require for your idea validation. Okay? Of course, for the next level of the productization also.
Was close to 3 years. So the difficulty was the development of a prototype of the product to test its form, fit and functionality. So from 1980 onwards, researchers have invented a new method of manufacturing prototypes. So at that time that was known as rapid prototyping, because compared to the conventional method of prototyping for a product, it was pretty fast as the transformation of the design idea, we call that as the design intent to the prototype, was directly from a 3D model data developed in a computer. So that was the era in which computer was also started its advancement. So later stage, different processes under additive manufacturing was invented, and slowly there were committees by ISO and ASTM, and they were thinking whether the name of rapid prototyping or another popular term was 3D printing, which was one of the layer-based technology process. So that was adequate. So they have later realized, there is a committee consists of academicians, industrialists, makers of the product, software, major industrial players, etc. they will be part of a consortium body like ISO or ASTM, that is meant for standardization for a given optimum order in a field. So that way they have decided that it is not correct to call the process as 3D printing or rapid prototyping, because by that time the process has grown exponentially, and people were inventing different methods for making products directly from CAD file or 3D model data. So they thought and find a suitable term as the fundamental behind the making of prototype or product is a layer-based approach. Previously, we had subtractive and formative based manufacturing methods for making products. So, in contrast to that, this process make use of adding material layer by layer. So, material could be polymer, it could be composite, metals, alloys, but the process of building of the product is from a bottom-up approach compared to the top-down approach that was conventionally followed. So that way they call the process as additive manufacturing. So as a part of your workshop, one of the fundamental course that you have to undergo is about the latest method for developing prototypes quickly before you realize a product, so that the form, fit and functionality of the prototype can be tested. That will in effect will tell the working behavior of your product under service conditions. So thus I hope the board is visible to you. Yes, all of you can see that. Yes. Thank you. So that way we were seeing the fundamentals of different manufacturing process. So we had subtractive based process. So in which there is a sharp edge cutting tool will remove material from a stock of material, and finally the required product shape will be generated. So which are the different kinds of subtractive based approach for manufacturing a prototype or product? How many of you are having, anyone of you are having a mechanical background? Few of you. Others are electrical. Electronics. Okay. Yeah. So okay, there are processes based on machine tools and cutting tools such as milling, turning, drilling, etc. that will remove materials in the form of chip from a stock. So that process was called as subtractive manufacturing process, and it was used extensively for prototype development for a long time. Another method of making product is by application of force and temperature and pressure in transforming the material from one shape to another shape. So that was called as a forming process. We are using automotive extensively in our daily life. You are seeing the styling of the outer surface of the car. So that is made by sheet metal process, and that is a kind of formative process. There is die, there is sheet metal in a particular shape, and we apply tremendous force and pressure in order to transform these sheet metal into the beautiful curvature, aerodynamic curvature that you are seeing in different cars of your choice. So that is a kind of forming process, and there were other formative process such as injection molding process that was extensively used for processing plastics or polymers. So a third category of manufacturing process which has started developing during the 1980s onwards is additive technology. So previously we had these kind of additive technologies. So for example, you must have seen welding, in which material from a rod with high temperature or pressure, different kinds of welding processes are there. Some processes high pressure is used for welding different parts. And most often we must have at least seen arc welding that is used by welders. So there also we are adding material. But the difference here is that when you use a 3D CAD data and the movement of your deposited head is controlled by a computer, that kind of additive layer process is called as additive manufacturing process. So even though there are other layer based technologies such as coating technology or welding technology, we don't call those processes as additive manufacturing. So additive manufacturing is a specific process in which the fundamental data that is producing your part should be derived from a 3D CAD model stored in a computer or the computer part of a machine directly. And the machine should choose the control points for the movement of its thread head or the energy source. It could be laser, sometimes it may be plasma, sometimes it could be electron beam, etc. But fundamentally it should take the direction from the CAD model, and layer technology should be applied for building a part. Then we call that process as additive manufacturing. So that way we have different types of processes that comes under 7 fundamental classes of additive manufacturing technology. So some of them are stereo lithography process. Then we have jetting process, material jetting process. We have selective laser sintering process. We have fused filament fabrication process. That way we have close to 7 family of processes for making parts by means of additive manufacturing. We will see those processes and its fundamental principles later. First we will try to understand some fundamentals of additive manufacturing based prototype development. Okay. So first of all, the definition of additive manufacturing. I was mentioning about the consortium that is formed for standards derivations in a particular field. So that way we have ISO standard, International Organization for Standardization. We have ASTM standards. If the product is from Germany, they have DIN standards. If the product is from Japan, they have GIS standards. If the product is from India, we have IS standards or Bureau of Indian Standards, BIS standards. So these standards will tell various guidelines and directions in regulating, controlling, and ultimately having a given optimal order of doing things in that particular field. So if there is no standards for gold, you know the kind of scenario. We are not sure what is the purity of the gold, whether it is gold itself, what would be the copper in that, etc. So with BIS standard, they have standardized what should be the ingredient and different processes and characteristics when you deal with gold, when it is converting, etc. So that you have a guarantee as customer that it will be having a minimum level of quality and reliability. So same way in additive manufacturing, we have 2 kinds of standard organization. One is ASTM standard, second one is ISO standard. So it started with the ASTM standard from USA, and later ISO was joining ASTM because they were so much advanced. By that time, ISO came into the field of additive manufacturing. Okay. So as per that standard, the definition of additive manufacturing is that process of joining materials to make parts from 3D model data using layer upon layer technology as opposed to subtractive and formative manufacturing method. So in that definition, as it is taken from ISO standard, I have highlighted the word of 3D model data, and I mentioned why the 3D model data derivation of making the product information is important, because we have other layer upon layer technology such as coating technology, welding technology, etc. We don't call that as additive manufacturing. So there were so many historical terms such as solid manufacturing, free form fabricate manufacturing, layer manufacturing, 3D printing, etc. But as per ISO and ASTM standard, the correct term is additive manufacturing. So the it's having it wrong. It will not take my laser. Yeah. You are seeing a grey color bar. So that is a complex heat transfer device that is used in aerospace for transferring the temperature that is generated during the engine operation. So you are seeing that there are so many intricate structure, and mechanical people derive very complex equation for effective heat transfer and thermal management of system. So if there was a time in which we can mathematically define various structures for transfer of heat very effectively from a source or a destination to atmosphere, but making that part was extremely difficult. So in additive manufacturing, as we are making the part from a 3D model data with the help of a computer, we call that complexity is free. You need not worry about the complexity of the part, whether it is having extreme kind of curvatures or natural organic surface structure or internal structure. You need not worry. That will take care by the process, because the process is very capable. At a time, it will just make one point, then a line, then a plane, and that plane is one layer. Similar to that, we can add upon layer on that particular plane and derive the part. So that way, complexity is doesn't matter in additive manufacturing, but that was not the case when we use formative or subtractive method of manufacturing. So those who don't have a background in mechanical, a typical method of producing part previously was using machine tools and cutting tools and its controlled relative motion, and the sharp edge tool was removing material from a stock in the form of chips. You are seeing the chips, and finally part is delivered. But in compared to that, in additive manufacturing, we are using very complex internal structure parts from polymer to ceramic to composite to alloys by means of either different energy sources. It could be heating of a wire, as in the case of fused filament fabrication or wire additive manufacturing technology. It could be in the form of powder, your raw material, and suitable lasers will be falling on that, and the powder will be melted and the part will be derived. It could be electron beam, it could be plasma source, etc. So different sources could be used for deriving the layer, but ultimately once the part is built, it will be having sufficient complexity. So a typical workflow of additive manufacturing route of making product or prototype will be something like this. So you have design or 3D CAD data that is stored in a computer. So the computer need not be external, it will be part of the machine sometimes. Then you have some methods of converting this computer data, 3D data into a STL file or a tessellated file in which we subdivide a complex surface into small parts in the form of triangles. So as engineers you must have heard about something known as finite element method, usually civil engineers, mechanical. No. Oh, okay, you have people from other background also. Okay. So usually when we have to analyze very complex parts, we try to make sub parts of the product digitally and representing them by triangle with its vertices. So that process is known as tessellation process. So in additive manufacturing or 3D printing, the first step is conversion of this 3D model data from a computer to this tessellated data. From this tessellated data, we have to get the information of one layer and other layers. Obviously, when you are having a complex shape, it is a very simple shape. You take any cross section. So it is having certain boundary and certain internal characteristics inside this. So that particular layer data should be derived from the tessellated model, which is derived from the computer generated CAD model. All these things are in digital form. So from computer generated data, it need not be always drawn using any software. You must have seen architectures drawing parts using AutoCAD or mechanical engineers using SolidWorks or CATIA or Pro-E to first draw the part. We are move away from the era of manual based drawing of parts with 3 views, etc. These days we are directly drawing the parts in 3D using various softwares. So from that 3D data, or the 3D data could be derived by other methods. For example, in biomedical application, we have different kinds of scanning. We have MRI scanning, we have PET scanning, we have CT scanning, etc. So these scan data from a patient's internal structure could be translated and converted into the tessellated file that I was mentioning previously. So it need not be always a CAD data that is derived from the scratch on a computer. It could be an MRI or CT scan data based on patient specific internal organs or patient specific implants, etc. We also have something known as reverse engineering in the industry. You know there is high competition in the market, and when new products arrive with different features and characteristics, people will try to mimic them. People will try to understand how their technology works. So even though its design and other details are protected by patents, sometimes there is trade secret, etc. that is used in industry, especially product-based industry. So in order to understand that, they want the internal data of the product. So we have computer tomography that is used in industry also, industrial computer tomography, to derive the internal structure. That can be used for metrological inspection, for understanding the defects in part, but also for 3D reverse engineering process in order to understand the internal structure, shape, etc.
We are moving to the third session. The third session, we have a speaker from CDAC Trivandrum, who is Mr. Ebi Joseph, who completed his BTech from MA College of Engineering, Pathanamthitta, then MTech from CET Trivandrum, and Sir joined as senior scientist in CDAC Trivandrum, I hope in the year 1998, and currently he is the level of scientist G, which is the highest scientist level in CDAC. and also he is a joint director in CEDAC Trivandrum of Power Electronics Group. With this brief introduction, it is a really immense pleasure for me to welcome the speaker of this function, Mr. Ebi Joseph from CEDAC Trivandrum. Welcome you, sir.
Yes, thank you, Dr. Kumaravel. I hope my screen is visible to you and I am audible.
Sir, full screen cheyama sir, full screen.
Yeah, I will do that. Is it okay now?
Yes, sir. Yes, sir.
Okay. So, thank you for this opportunity for sharing some of CDAC's experiences in general and some of my personal experiences to a gathering, a technical gathering. And thank you, Dr. Kumaravel. So today I am just planning to give you a quick a presentation on development of lab scale prototypes and field deployment of power electronics systems. So I basically represent the power electronics group of CRACT. We work in different areas of power electronics systems. Hope I am audible.
Yes, sir. Yes, sir. Now screen problem. Now it's all okay, sir. We have enlarged the screen. Please go ahead, sir.
Okay, fine. So I'll just give you a brief about CDAC, its structure and how the projects are undertaken and all. And then I will just show you some of our projects, how they have been developed and how they have been put under trials in actual field. So that will be the total overall picture of the project actually. So CDAC is an R&D organization of Ministry of Electronics and Information Technology, Government of India. So we are basically carrying out R&D in IT, electronics and associated areas. So we have something around 14 laboratories spread over the country, about 3,000 employees involved in design, development and deployment of electronics and advanced information technology products and solutions. Our headquarters is at Pune, and CDAC Tirunelveli is more focused towards professional electronics. In CDAC Trivandrum, basically we have R&D focus area defined as power electronics to do broadcast and communication, hardware design, control and instrumentation, strategic electronics, health informatics, cyber forensic and education and training. These are broadly the area where CDAC Tirunelveli is working. Power electronics is one of the major groups of CDAC Tirunelveli. Now, our expertise, Dr. Kumaravel, is there any disturbance? Hello?
Is it all right, sir, now?
Am I audible properly?
Sir, you are absolutely all right, sir. No problem.
Okay, fine. So if some disturbance was coming, that's why
I think the mic from our end also turned on. I don't know, sir, how to turn off. Please go ahead, sir. We'll see.
Okay. The power electronics expertise, actually, I understand that it is a heterogeneous audience. So I'll be mostly focusing on the power electronics. Power electronics as such is a multidisciplinary kind of a technology. We have different components of the technology other than electronics there. So if you look at the power electronics expertise of CDAC, we have power and control, hardware design and development. Then we have capability of real-time control software design and development. Then we have capability of system engineering, product realization and developments. Operation and maintenance is another area because that is also important as an R&D group. Operation and maintenance usually don't come in our purview, but nowadays all the funding agencies expect CDAC or any such organization to take the technology from lab to field. So once it is in the field, then the picture is different actually. So when I will come to some of the projects, when the system is in the field, we have to ensure that it is maintained and kept in proper shape for quite some time. Then actually after technology demonstration, we go for a technology transfer to industries on a non-exclusive basis, and we transfer the technology to industry, and they productize the and go for mass production according to their plans actually. That's how we operate in projects. And then nowadays we are also executing turnkey projects. So I'll come to one example there. Turnkey projects in the sense we will take a specific project where technology indigenization is required, and we'll go for turnkey implementation with the user agencies. When it goes to the field, we have to focus on operation and maintenance also. Then actually after technology validation or demonstration at the field, we go for technology transfer, where private industries are given opportunity to take technology, engineer and productize it actually. So I'll come to some of the examples at a later slide if time permits. And we also work on turnkey projects. So whenever there is some technology indigenization required in a certain area, we go for turnkey project execution, where we will use our indigenous technology to build the overall system. I will come to an example later. And then different technologies we are working actually. Those who are familiar with power electronics will know about all these technologies. That is power quality solutions, and then smart grid solution. A lot of intervention is required from power electronics domain for realizing the smart grid. Then we have distributed generation like solar power plants, distributed generation and microgrids. So these are domains where power electronics is the key technology used for power conversion. Wide band gap device, new device physics that is coming up, and there are new power electronic devices in the is taking more. It is becoming more important because of certain characteristics of these devices. So, but at the same time, we have to the design aspects are also changing. So we are working on such area, that is new horizon areas of power electronics. Then as we all know, the energy storage interface designs are also very important. Then industrial drives are required, EV propulsion, electric vehicles. So there are requirements of EV propulsion system as well as charging infrastructure, and energy efficiency and LVDC power distribution is another area. Then of course high voltage power electronics. We know all about the and we know about the high voltage transmission, where power electronics has a big role to play, and other systems also are there where high voltage is a requirement. So controlled high voltage usually requires a power electronic interface. So these are some of the technologies where we are doing projects actually. So and these are again a glimpse of some of the work that we are going. It's almost similar to what in the previous this one. And we also say that there are some new areas where we are going to work. It is MEMS-based sensors for power electronics. Then wireless power transfer in kilowatt range. So these are areas where we are presently working actually. And then there are many products coming out of PEG lab, that is Power Electronics Lab of CDAC. We have up to megawatt scale grid interactive solar PV power plants. We have different types of power quality products, STATCOMs, active filters. Then we have smart grid technologies like PMU, VAMs, and all. Then 10 kV DC-DC converter program. So this is basically the high voltage power electronics area. Now I will introduce one area, one activity of CDAC. In fact, the Ministry of Electronics and Information Technology. It's a mission program called National Mission on Power Electronics Technology. We call it as NAMPET. In fact, NIT Calicut also is a part of NAMPET. And we had phase one of the NAMPET from 2005 to 2010. Phase 2 was in 2012 to 2018, and phase 3 was 2019 to 2024. This particular activity is designed in such a way that it encourages collaboration between academic institutes, R&D institutes, industries, and user agencies. The projects are conceived in such a way that every project coming out of this NAMPET basically involves collaboration from different institutes in different levels, basically. So, in NAMPET, as I have mentioned earlier, again it is aligned to the activities of Power Electronics Group, and CDAC Thiruvananthapuram Power Electronics Group is the nodal center for this NAMPET program. So this is one of the major research programs happening in the country, government funded research program in the area of power electronics, actually. So as a mandate, we have been asked to contribute to Make in India and make India a dominant player in the power electronics technology. So now, so basically the concept of NAMPET and the focus area, I have mentioned previously, there are real-time simulation and emulation devices and DC-DC converters. I was mentioning wide band gap devices. So in fact, devices and DC-DC converters, high voltage power electronics, AC drives and e-mobility, real-time control, because different controller requirement. I will come to one slide where I will just explain what is meant, where this control is required actually. We have a good R&D facility at the CDAC. We have a 500 kVA, 11 kV bar 415 substation powered power electronics lab. You can see different systems being getting tested in the lab. So and also there are other areas like we have a control lab where people work on design, simulation studies and things like that. And then there is a medium voltage and the drives lab. There is a facility for CDAC in Technopark campus also, where we mostly work there in the green energy area. Presenting in terms of NAMPET phase 3, because almost all activities of power electronics CDAC Thiruvananthapuram are aligned with the National Mission on Power Electronics Technology. Definitely, we have other projects. Other projects means contract projects from private industry, projects coming out from other funding agencies like DST, Department of Science and Technology, Department of Heavy Industries. So such projects are also there. So, but a major part of the manpower is presently aligned with the NAMPET. So in the NAMPET, there are 4 focus areas. One is application-oriented research, development, and deployment. New Horizon in Power Electronics Technologies is basically the R&D projects where academic institutes will be mostly involving. MIT Calicut was doing one project previously in the area of micro PMU. Similarly, such institutes, almost every IIT and major NITs have different projects. So these are basically not to go for field deployment, but the TRL level expected maybe 4 or 5 like that. So some laboratory prototype will be built, and the system testing and result validation will be done in such projects. Then there is another area that is wider deployment of technologies developed in NAMPET. That is, these are technologies which basically the development cycle is completed, and we take it towards a field with the support of a user agency, and the user agency, with the support of user agency, the system will be deployed at a real site for real application. And the system will be taken care by both user agency, CDAC, and if there is any industrial partner, the industrial partner also will be given some kind of a responsibility. And then there are technology outreach programs. We conduct seminars, workshops, something like that. So coming to New Horizon Power Electronics, I was just mentioning areas of WBG devices, reliability, system integration, miniaturization, high frequency, high performance magnetics, MEMS, application in power electronics. And then in the consortium, actually this will be done in a consortium mode, but multiple academic and R&D institutes will be there in the New Horizon projects. And there are certain exploratory projects from the academic and R&D institutes, where actually the project from Dr. Kumaravel, project by Dr. Kumaravel fits in this category, that is exploratory research. In consortium of project, what happens is multiple IITs, maybe multiple IITs and NITs will be working for a bigger objective, and they will divide individual responsibilities, and they will give individual output for and one institute will combine all the things together to make a bigger objective actually. So this is how the New Horizon Power Electronics projects are done. And the deployment of technologies. So we have microgrid technology, we have green energy systems for community and school buildings, we have deployment of wide area monitoring systems. So many are there. I just mentioned like this. We have LVDC project. So these technologies are basically somewhat stabilized, and we try to deploy it in actual place, actual location. For example, microgrid village. Actually, it's a good technology for electrification of remote and rural settlements, area monitoring. So many technologies are almost stabilized, and we are working with the user agency for larger deployments. So this is the concept of deployment of technology and development in Amazon. So for example, this microgrid is getting deployed in multiple villages in the project actually. Microgrid is getting deployed in multiple tribal village. We have three streams. One is e-mobility, smart grid, high voltage power electronics. So we have certain facilities used for pre-compliance testing. For example, we have a thermal chamber for dry heat and thermal cycling testing of the system. Then there is an EMI pre-compliance system. So why I am showing these slides is actually if there is a laboratory prototype, when the laboratory prototype technology is translated into a product which has to go to the field, all these things are actually required basically. That is why, so I was mentioning about the TRL level. To achieve the TRL levels, all these things will be required. Now, Dr. Kumaravel was asking how basically in CDAC, how the projects are implemented, how projects are basically planned. So it starts with the conceptualization of a proposal or a product. So the conceptualization of a proposal or product means it can be through from an inquiry from an external agency. It can be a new concept, that is coming up. It can be some import substitution requirement. So based on that, we will go for a proposal. During the proposal, we will form a consortium. Consortium in the sense we may have technology partners like academic institutes. We may have other partners like user agencies. User agencies can be some renewable energy agencies, or in utility grid agencies, or drive industry, anything. So usually for every proposal, we'll have an academic partner and an industry partner. So every proposal is formed like that. And then we do some kind of jointly, we do some initial surveys, initial literature survey, and then form the proposal. And we define the proposal. Usually, as I mentioned before, the project support or funding support comes either from the government or from private, or from public-private jointly. So then after project approvals, we make individually a project execution team for the individual project, and then we form the product requirement specification in detail. Hello?
Please go ahead, sir. Go ahead, sir.
Okay. Hello? Okay. So literature survey, then preliminary design, simulation studies on how hardware and software that is control methodologies. Simulation studies, different simulations are required actually. So simulations may be required on the device level. Simulation may be required on the thermal management level. Simulations may be required on the magnetic circuit level, and combined simulation of the power circuit may be required. Similarly, we need many control algorithms for different applications. So the control methodologies are also required actually.
Do you know what is there inside this bottle? Will be some sort of liquid, right? I am going to tell you a magic by science, by which this liquid will transform to something like this. Okay. Want to take a close look? You can see it. Are you getting it? I want everyone to touch it. It's actually a cleanser. And this is not still purely cured. So we were doing it yesterday night and we just took the prints just for showing you guys. Now after the session maybe we can take a coffee. So the mission, what you see right here, does this do. So these are basically known as SLA missions. Forget the name, basically some mission which will convert some liquid like this to something like this. Okay, forget the name. And we have another mission here. It has got a spool of plastic. You can see, this is a spool of plastic. Forget the name of plastic, some plastic. And this machine is going to melt this plastic. And it can make parts like this. Okay. And even something flexible. Parts like this. Yeah. Don't look at it. Answer. Don't probe those products, they are very fragile. So, we want to see how it is made. Okay, so before getting into the actual process, okay, anyway, we will do one thing. We will try to print a small sample and let the printers run. It's a half an hour or 1 hour long print. We will see if we can finish within time, or else if it reaches 4:30, then we will pause the print and we will take the model out and show you how it is done. Okay, so as I told, as I told, this is known as SLA printer, stereolithography printer. So what it does is like, it has got a resin inside, and this resin is photocurable resin, which means before opening the bottle, I have to stir it. Yeah, and I forgot one thing. I forgot to wear the gloves. So there will be a slight foul smell of this resin. If there are any allergic issues, someone is allergic or anything, we will open the windows or they can move back. Okay? Be careful. Sorry, I am not wearing any goggles. Ideally, you should wear goggles and mask. But anyway, it's like a very small quantity, so I am not wearing it. So you can see, sometimes you cannot see from there, but it's a liquid. It's a small liquid there. But if I irradiate this liquid, what is this? A laser, right? Some type of laser. But there is also some blue light. This is actually ultraviolet air radiation. Okay. So if you irradiate, yeah, maybe the dentist will be knowing it.
lenses are there?
Where are those lenses? Yeah, you know it, right? The UV, QR, the same stuff, same stuff. You cannot pour this on your mouth. Anyway, so if you ready it for some time, maybe yeah, very sure. Yeah, don't touch it. You can just hold it like this. Hold it for some time. And what happens is that an irreversible chemical reaction happens. Basically, some sort of polymerization. In short, it becomes solid. It's just like the dosha ma or the dosha batter. Once you pour out the hot pan, what happens? It solidifies, right? As simple as that. So instead of heat, here we are using light because heat is difficult to control, but light we can control it very precisely. So in this printer, what we have got is yeah. We have got a tub which will contain this resin. So you can see, here you can see very clearly. Okay. There is some white color liquid, and there is a transparent sheet at the base, right? Yeah. I do. So here if you see, this is actually solidified. Yeah. Do you see this? Now I will explain how this machine is working. As I told, there is a rack where we will be pouring resin. And this thing here has got a screen. Do you see? A black color screen. This is nothing but an LCD screen. So the same thing what is there in your mobile phone. And how it works is that this screen is transparent. Our mobile phone screen has got a mirror-like finish at the back side, right? Maybe the electronics students or physics students will appreciate that. So there is a Polaroid screen and there is a mirror sticker at the back. So what it does is like it reflects the visible light. Or in some cases, it has got, in regular mobile phone screen and it has got a strip of LED, or earlier in the CRM monitor and all, there used to be a small fluorescent tube at one side. And there is an acrylic grating by which the light is reflected uniformly. So in this product, what they have done is that they have removed that mirror-like sticker and they have directly placed that Polaroid screen, that LCD screen, on top of this machine. And you have got a special kind of file. Engineers will know it is known as STL file. So what it does is like, if you want to print, for example, if you want to 3D print this product, as I hope that some faculty might have explained about it earlier, the first process is that it will do slicing, which means the computer will chop off this 3D model to multiple layers. The more layers it has, the better the finish it will have. Okay, it's just like a, can you give your book? This is what? This is a book I know, but geometrically it is a solid rectangular, what do you call? In mathematics, what do you call? Rectangular cube or, yeah, rectangular cube, right? Cuboid. Okay, anyway, I don't know. So, this rectangular cuboid consists of what? Layers. Layers of paper. Instead of that, yeah, this thing virtually the computer will make. And this computer will send data to this machine, and what the machine does is that each time, sequentially it processes layer by layer, which means initially the first layer will be 3D printed. Then this thing advances a little bit and the second layer will be printed. Like that, finally the whole shape will be 3D printed. Yeah, I will show that in detail. Okay, and another important thing, this printer prints products upside down. So some of you might have thought about what are these trusswork? These are actually known as support material. Basically the main function of this thing is to support the parent structure or the design what we want to make. So this thing will be stuck like this, and it emerges from this vat filled of resin. It is formed layer by layer. So initially this top layer will be formed. Then subsequently each layer will be formed and finally you will get this shape. Since it is an optical device, which means the resolution can be really good. Okay, you will get something like 0.2 millimeter like that. Even with good accuracy, like you will get accuracies like in micron levels actually, because it is light, right? Yeah. And they are using which light? Blue light or ultraviolet, which means the wavelength is what? It's very short. Okay, so you can get really fine resolution. Yeah. Now let's come to this predicament. Oh, nice. Thank you. Yeah. So in this machine, what it does is that, do you see this part? Yes. It is known as hot extruder, or it is an extruder. Yeah. So this spool, what you see here, if anyone wants, you can come here and see. It has got a filament, and the diameter is very specific. And here, can you turn the camera? Yeah. This thing is known as extruder motor. What it does is like, it pushes the filament to the hot extruder. This is the hot extruder. This thing. So essentially, you all know about idiyappam, right? I hope, are there anyone from North? Yeah. You know idiyappam, right? Maybe someone, I don't know what is English name idiyappam.
Rice noodles.
Rice noodles, something like that, you get in the mess, right? Okay, anyway, maybe someone can cook her and, maybe, yeah. So, or murk or jalebi, yeah, you know about jalebi, right? Jalebi, yeah. How they are making it? There is some hot oil, right? And there will be the jalebi batter, or I don't know what you call it. And it will be poured onto the hot oil. Then what happens? It solidifies. Then why this jalebi, that batter is not really becoming like, like chai. When you pour milk to water, it spreads evenly, right? Why doesn't happen in jalebi? Yeah, even if I pour some highly consistent curd to water, it just dissolves or disappears. Yeah, but more importantly, the oil is hydrophobic, and the batter it's actually contains water, right? It's a hydrophilic thing, so it won't really mix as such. That is why if you violently agitate it, it just becomes like droplets or globules, right? Yeah. And there is one person, experienced fellow, who will be doing this process. And I don't think any chef or any cook or a jalebi wala buyer in the world has ever made to replicate the same jalebi. Why? Why? Benito, yeah. Why they are not able to replicate it? Yesterday he was helping me in making the slide. By the way, they are all my interns, so yeah. Human error. Human error, it is impossible to be consistent, right? Because there are n number of variables what can happen if I need to execute a motion like this. Because this is not like a CNC thing, right? It is controlled by brain. Brain kaisa bhi jata hai, right? And more importantly, this motion is achieved by numerous muscle strands, right? So imagine this motion is automated and you are giving it to a robotic arm. What you will get? It will be impossible to get variations. Okay? Yeah. Great. So that is what. If you give this process to a machine, you will get repeatable results. That is the advantage of removing subjectivity of this sort of processes, especially in prototyping and using technology. So the art is done by whom? An artist. An artist does something according to what he thinks. Right? And what is the difference of a craft? Or can you tell me an example for an art object or art product? Maybe this thing. I don't know, what is the name of this? Yeah, I'm not a Star Wars fan. So Yeah, this thing. It almost looks like an art piece because I couldn't see any proper functionality. Sorry, yeah. I don't know. Or maybe some painting done by Picasso, whoever. Or some sculptures you will find somewhere in the middle of road, standing for no reason. Why these products are significant? How does it contribute to the society? Or how does it contribute to the technology? Generally, we engineers, okay, I was also an engineer, but now I am professionally a designer and an entrepreneur. But generally, we engineers call ourselves as problem solvers, right? So, are artists really solving any problem? What problem? Or are there the sculptures? Whenever I see a sculpture like in front of middle of a road, I feel like it's a new problem which is created. And we need to invent some sort of technology like mirror, in this way, in this direction, traffic light, policing, or pura gadi, whatever. How does it,
It's a simple.
Yeah, simple. So basically, art is supposed to disrupt the monotonous life. So you are just going in a bus like this, and maybe you are seeing a sculpture from middle of nowhere, and you see, oh, life can be like this as well. Someone is highly disproportionate. Sir, itna bada hai, the body itna patla hai, something like that. Oh, aisa bhi ho sakta hai. Yeah, it's interesting, right? And generally, this art, even if it is a picture or whatever, it is up to the user to or the viewer to interpret the meaning. Okay. But when it comes to craft, it is done. Art is generally not done by machines. But nowadays there are machines does better art than what humans can really create. Anyways, that is not a topic for today. Maybe for a different day we can speak about it. But when you come to craft, what happens is like the craft actually does what? It has got a purpose, right? Can you tell an example for a craft product? The bamboo mats or the pottery. It has got a purpose. Mat is supposed to be used somewhere for something. The pottery is supposed to be used for something, right? Yeah. When it comes to design or engineering product, what is the purpose of this thing? Is it an art product? It's an art piece? No. It is functional, which means a designer or an engineer never designs something for himself or herself. Then to whom we design for? Customers or consumers? Both are different. Yeah. Users, basically you can say users, right? And there is an intended use for each of the product. Right. Craft is also the same, but it is not industrially manufactured. And people like me, industrial designers, where we work is that generally what engineers do, they translate one technology to a product, to something functional, right? Maybe something can amplify my sound and reach till there, or it can teleport my sound to US or to Mars or to anywhere, right? And ultimately there is an experience because humans are not machines. Humans look for experience, right? If the same content, maybe I am printing and giving to you, I don't know how many of you listen. But when I give these 3D printers or the 3D printed models or whatever, sometimes it helps to understand or helps to realize it much better. So we value emotions. We need what? Yeah, imagination. Basically we need to use our own creative skills and each one want to get their own feeling from whatever you design. Okay. Am I deviating from the topic? Why it is important? Why I am telling all this story? Because I want to highlight the importance of rapid prototyping. Because in the present world, there is a huge difference what we have got. Why BTech graduates are not really appreciated by whom? Society. Okay, I got the answer. Everyone knows about Calicut Medical College. Is there anyone in this room who is unaware about Calicut Medical College? Everyone knows about it, right? Even the lawyers know it, everyone knows about it. But how many of you really know there is something known as IIT or NIT? Maybe, probably you guys are here, so you know definitely, I know. But if you take a survey, like how many of them know? Acha, bada building hai, acha, kuch hota hai andar. Okay. Or if a fellow, someone has got some illness, they will go to dentist, some toothache or something, I will go to the dentist or I will go to somewhere. Okay, right. If there is any land dispute, I will go to the lawyers, right. But why the layman is not really approaching the engineering colleges? भैया मुझे एक product बना के दे दो, मेरा आवाज उधर तक पहुंच नहीं रहा है, कुछ बना के दे दो. क्यों? Why? We are good at technology, right? We are good in technology. Which department you are? Electronics, yeah. You know about signal processing, blah blah, everything, amplification. क्या है? DGK से download करो, वो हो जाएगा, right? हो जाएगा. But why it is not getting translated to a product? Because still, I don't know, it's a Sennheiser mic. Still it failed. Or the product never works. AC never reaches to us. Still, our camera operating person, he has to carry the camera everywhere. Still, we need to do a lot of adjustments here. Then, मतलब क्या पुराना समय में जी रहा है यार? In what era we are living really? Even the government has digitized a lot of forms, everything, you know, Aadhaar card. But still, engineering college में क्या होता है? वो पुराना समय 200-year-old age machine पे अभी भी चलता है ना? Where are those CNC machines? NIT also we have got a beautiful CNC machine.